Hello everyone, I welcome you all in this C programming and data structures lecture. This is part 3 of reversing a stack using two stacks. So without any further delay, let's get started. We got stack underflow on the console window after executing the following code. In the previous presentation, we have executed this code, right? And after executing this code, we got stack underflow, if you remember. Now we will try to find the reason behind this, that why we got stack underflow after executing this code. Here we are passing top pointer to this push function. We are not only passing the data, we are passing the top pointer. This is what we have learned in the previous presentation. If we pass the top pointer to the push function, then it would be better, because here we need to pass the top 1 and top 2 later. That is why it is important that instead of declaring this top pointer globally or these two pointers globally, it is better to pass them locally to the functions, right? So that we can perform operations on the temporary stacks as well. That's what we have learned in the previous presentation. Now here, after executing this code, we got stack underflow message, right? Which means stack is empty. Now what is the reason behind this? Why we got stack underflow? Let's try to understand this and let's try to debug this code. Here up to this point code is working fine, but when we try to print top, which means when we try to print all the elements of the original stack, we got stack underflow, right? After calling print function, we got unexpected result on the screen, that is stack underflow. What could be the possible reason? The problem is there in the print function, therefore let's try to debug our code by examining our print function. It is very important that we must examine our print function so that we could debug our code, right? Here is the print function and you can see I'm checking this condition over here. If stack is empty, if my original stack is empty, or if top is equal to null, then print stack underflow and exit from the program with exit failure status. That's what we got in the previous presentation, if you remember. Actually, we got the stack underflow message. Along with this, the process also returned 1, right? There is no doubt about this, that after calling this print function, this piece of code is executed and this condition is actually satisfied, which means that top is equal to null, right? Stack underflow occurs when stack is empty or top is equal to null. Let's get back to the caller and see why top is null. Now it's time to examine our main function. That means it's time to examine our caller. Why we got top equal to null? Here obviously this print function is receiving null, right? Top is null. This means push function is not working correctly in pushing an element onto the stack. What do we mean by top equal to null? You can see this, the top is initialized to null, which means that initially stack is empty. After calling the push function, 1 must be inserted onto stack, which means that the stack is no more empty. And this means there must be at least one element onto the stack. Therefore, top can never be null in this case. Hence, it is true that there must be some problem in this push function, right? Maybe this push function is not working correctly. And this might be the reason why we got stack underflow on the screen, right? So let's shift our attention to this push function. Passing top means passing the value of the top, right? Please understand this, here we are passing top, which means we are passing the value of the top, okay? Although top is a pointer and we know this already, that it is nothing but a special type of a variable which stores the address of something else, some other object. Here top is initialized to null, which means that null is passed to the push function. Later on, after completion of this push function, this top pointer must receive the address of the first node, right? And first node must hold this value 1. Maybe after calling this push function, top pointer is not receiving the address of the first node. This is what we should understand. Here we are passing top, which means we are passing the value of the top. And in other words, we can say that we are passing the copy of the top. Now here, we know that top pointer is currently holding null. Therefore, null is passed to the push function, right? So we can replace this by null. And here in this push function, this top pointer will receive null and data will receive 1, right? So we can say that top is null and data is 1. This top pointer is local to this push function. Please remember this. This top pointer is local to the function push. We should always remember this. We cannot confuse ourselves with this, that this top pointer and this top pointer are same. Please understand this. This top pointer is local to the main function and this top pointer is local to the push function. They both are different, although the name is same, right? I have color coded them differently so as to avoid the confusion. Now, let's see this piece of code. We know that with the help of this piece of code, we would be able to create a new node. That's what we are doing here, right? So a new node is created and new node pointer is currently pointing to this node. You can see the address of this node is 1000. Link part is holding null and the data part is holding 1. This is our new node. My assumption is that the address of this node is 1000. It can be any address, I don't know, right? Now here after this we are updating new node link by top. Top is null, therefore this will be null only. After this we are assigning new node to top. What do we mean by assigning new node to top? We know that new node is pointing to this node, which means that new node is holding the address of this node. The address of this node is 1000. Therefore, we are trying to put this address over here in this top pointer, right? So null will get replaced by 1000 address. Fine. Everything is making sense up to this point. But what about this top pointer? What about this top pointer? This top pointer will never receive the address of the new node. Understand this. This top pointer is local to this function. After the function finishes its execution, this top pointer will get destroyed. And this top pointer will never receive the address of the new node. Think of this as call by value. Here we are passing the copy of this top pointer to this top pointer. And that's it. This simply means we are passing the value of this top pointer to this top pointer, and whatever the changes we are making here in this top pointer will never get reflected back to this top pointer. That is why this top pointer still remains null. Understand this, that this top pointer is in the main function and is local to this main function. That is why this top pointer remains null, right? Now you got the reason why we got the message stack underflow. Our push function is working fine, but the changes that we are making to this top pointer will never get reflected back in this top pointer. And this is the reason why top is still null, right? But there is a simple solution to this problem. Actually, what we can do, we can simply return top from the push function. We can return this top from this push function. It is simple. We can simply write this line of code, return top, and here we have to replace void by struct node star, because we know that top is the pointer to a struct node. That's why we must replace this by struct node star. And here we must write top equal to push 1 comma top, right? In this way, this top pointer will receive this address 1000. So therefore, this null will get replaced by 1000. Simple. In this way, we can call multiple push functions and we can push all these elements onto the original stack. It is not difficult. Later on, we can call the print function to print all the elements of the stack. Obviously, we will get 3, 2, 1 as the result. 3 must be the topmost element, 2 must be the second topmost element, and 1 must be the last element of the stack, right? So after calling the print function, we must get 3, 2, 1. Fine. Now, let's execute this code. Here we have a struct node, we have isEmpty function, we have push function. And here you can see I have updated this push function. I have put this line of code, that is return top, and here I have replaced void by struct node star. And here we have this print function. And in this main function, you can see top equal to push 1 comma top, top equal to push 2 comma top, top equal to push 3 comma top, and then finally a call to a print function. Let's execute this code. You can see the output, the stack elements are 3, 2, 1, right? These are the elements of the original stack. Fine. And you can see that the process returns 0, which means that our code is working fine. In the next lecture, we will update the pop function. We have updated our push function. Now, in the next presentation, we will update our pop function. Okay friends, this is it for now. Thank you for watching this presentation.